Hello, everyone. As usual, we'll start around 11:10 with a quick quiz. And then after 15-minute quiz, we'll continue and I'll show you a few example questions that you might be asked about the material we learned so far. And after that, I will be happy to answer any questions you have about the lecture, slides, anything else related to the course. Just let me know after the tutorial is done so you want to talk one-on-one. Okay, hi again to everyone who joined us recently. Uh, any questions before we start the quiz? It will start officially in 2 minutes. Any questions you guys have that you want to ask, please post it in the chat. And again, I repeat it one more time. If you need some personal help or you had some questions, please send a message for me in the chat and stay after the tutorial is over. I will move you into one of their breakout rooms, and there we can talk one-on-one and you can ask your questions. Can someone confirm you can hear me well? Thank you. Okay, you should be able to start now. Good luck and see you in 15 minutes. Okay, I hope most of you already done with the test. So let's start today's class. As usual, please turn on your cameras if you can safely do so I can see, how clear I am and I can see your reactions to what I say. Are there any questions? Can you guys hear me well? Yeah, again, yeah, the same simple request. Please turn on your cameras, at least some of you. Okay. So the plan for today is to just go over a few related questions on what I covered in the lecture on Wednesday. Remember, the next and the last big piece we learn in building the processor is the control flow. So we figure out how to actually connect pieces together and control them. And a big part of the control flow is a data flow path that you need to identify depending on what you want to execute at this moment. And I think we spend a lot of time practicing several different options, and we will keep doing and practice that because that's important thing to understand about process operation. Okay, so let's start with one warm-up exercise here. And the question we have here, and I want you to try it out and type your answer in the chat, is assuming that you had a memory, a RAM unit that has only 6 address bits going into it, and given that you have a 32-bit architecture, how many integers is your RAM can be able to store? Yeah, please ask questions if something is unclear, and then essentially I expect some answers in the chat. Yujan, you're asking how many bits in integer time. I already told you in the question it's a 32-bit architecture. So when someone says you it's a 32-bit architecture, it means that the baseline integer type is 32-bit. So when someone says you it's a like, for example, if your machine is 64-bit system, it means your integer is 8-byte. Okay, any answers? It's a relatively simple question. You just need to be careful. Okay, one answer is 16. Any other opinions? I hope we have more people participating actively and trying to do, even without cameras. Okay, 16-8. Any other opinions? So we'll check soon. Okay, anyone else? Guys, please, that's the whole point of here is to practice. Okay, I'll have to move on. So the first step, obviously, is to convert, wow, 2 to the power 26. That's a lot. So let's have a look. So you had 6 address bits, right? So the maximum amount of bytes you can represent using these bits, assuming you want to address every single byte, is 2 to the power of 6. right? Memory slot, because this 6 address bits needs to be able to address every byte in your load. So 64 bytes total is how much memory you have, right? That's the total memory if you only had 6 address bits. So 32-bit architecture means it's 4 bytes per integer. So that means I can store 16 integers in memory. So the first answer from Yujan was actually correct. Okay. Any questions about the logic? Anyone confused or not sure about how we did it? So essentially, address bits tell you everything you can address, right? The whole range of memory. And then you just do 2 to the power of this number of address bits, and that gives you the total number of bytes you have. Okay. For example, one of the reasons why people go through a 32-bit system to 64-bit systems is because in 32-bit systems, the number of bits that can be used for address was limited. So, and that essentially, we were not able to represent anything beyond 4 gigabytes. You probably don't remember when this problem arose, but say, I don't know, around 10 years ago, when people see this limitation, that's where there was a strong push for 64-bit systems, because the address space is much larger, because 4 gigabytes was very limiting already. Okay. Any questions? Okay. Another question. So big thing about the data path is understanding what's located where. So you kind of want to understand the basic logic here. So let's practice how you remember the data flow path. So essentially try to type here first for number 1. So what is in the number 1 located? I'll wait for the first 3 correct answer and then we'll move on. So what is the number 1 on this figure? Okay, that's correct. So we're getting correct answers. I hope people will be a little bit more active, but yes, this is program counter. That's easy. So how about number 2? Who remembers that? Yes, that's memory. That's correct. That's the memory part. Okay. How about number 3? And again, you can check yourself later on with the slides if you want. Quintan, can you be a little bit more precise? You said instructor, but what exactly is there? So Terry, there is not such one single thing as control unit. This whole thing is somewhat as a distributed control. Yeah, George said the correct thing. This is instruction register, instruction decoder. That's where the number 3 is where the instruction is located. 32-bit, right? Instruction, 32-bit system, and that's where we read it parts by parts in different things. Okay, number 4. I hope everyone knows number 4. Yes, register file. That should be easy to recognize. It's a big thing. It takes a lot of space. Very important by the sheer part of it. Okay, number 5. Okay, great. I'll use. Okay. How about number 6? So number 6 is not sign extension. That would be number 7, I believe, if my memory is correct. Number 6, if you look carefully, it looks from the memory, right? So that's like a memory register. So you got the idea, right? So so you can practice at home, so you can roughly remember, especially for the exam, so you can not waste time on looking somewhere. You understand where the basic blocks are. Okay. Okay. Let's practice a few more questions. Okay, so question number 1, where the instructions are stored. So we answer question one by one. those questions might sound simple, but it really tests your fundamentals, so you really understand what's going on. So yes, a lot of things I'll clarify. There's a lot of things that students sometimes don't understand, that most of the instructions, when you write your code, it's compiled and stored in the binary format. There's no other place to store anything other than memory. So at the end of the day, everything is stored in memory. I can store pieces of instruction and instruction registers. I can store some of the instructions in my cache, but overall, my binary can be so large that it doesn't fit neither into the register or the cache. So there's no other place for it to be stored other than memory. That's where OS puts it. So it stores alongside the data values. Okay. How long is a single instruction in a 32-bit system? In bytes. Yes, several people answer correct. That's just 4 bytes, right? I repeat it multiple times, right? It's just 4 bytes, 32 bits. We spend a lot of time to decoding those. There is a strong assumptions in the system that, in MIP system that we played with, is that every instruction is the same length, right? That simplifies the decoding dramatically. Okay, another question. What is the role of the program counter? Why do I have a special register for that? Oh, anyone? Program counter. Yes. It shows you the location of the current instruction, right? And as you read it, then you move it to the next instruction. So you're not completely incorrect. So it stores it at the beginning of a processing. It stores the current instruction. As you start to process, you push it to the next instruction. Remember, +4, it's the next instruction, right? But at the beginning of a processing of each instruction, it points to just that instruction. Okay, is this clear, guys? So eventually it changes to the next, but at the beginning, it's this precise instruction. Okay, any questions so far from anyone? Okay, what do we mean by instruction fetch? So several times I said we fetch the instructions. What does it mean to fetch the instruction? Exactly. So you just retrieve an instruction from memory. So remember, everything is in the memory, but for me to start do something minimal with instructions, to do decoding, to take different bits, I need to read it from memory into my instruction register, right? That's where I'm going to deal with it. And the last but not the least thing I want you to remember, so when we process the instruction, it's being executed using the instruction register, okay? So this is just kind of warm up for the relatively complicated material we covered on Wednesday. So hopefully if you don't understand certain aspects or something was not clear, you will revise these materials. I'll keep bringing in the future tutorials more and more questions, sometimes related to the this week's Wednesday's class, and gradually more about the assembly. Okay, any questions, guys? So on the weekend, we will get some videos about how to proceed with the future lab and the project. So that will be posted hopefully on the weekend. Okay, any questions? Okay. If there is no questions, this is everything I want to have for today, not to overload you guys. Please, for people that want to have one-on-ones and use the benefit of office hours, let me know right now, and I'll bring you into the breakout room. Otherwise, thanks a lot, everyone. Thank you, guys, and have a nice weekend for everyone. Hello. Can you hear me?
Yes, I can hear you.